digital filtering of audio signals. The audio we selected was audio 11. In this assignment, we will be focusing on to identify these unknown and unwanted noisy signals. Secondly, to eliminate the corrupted audio signal using FIR and FFT based, which is frequency domain filtering method. The equipment we used was laptop and MATLAB software. For the intro, a digital filter is a numerical algorithm that eats away at the digital informational index, for example sensor data, to retrieve interesting data and delete irrelevant data. Digital filters are divided into two types, which is infinite impulse reaction, which is IIR, and secondly finite impulse reaction, FIR. The unintended motivation response is a type of digital filter used in digital signal processing applications. A filter's function is to allow some types of signal to pass while preventing others from doing so. Because it employs a feedback mechanism, the infinite pulse response filter is unique. It requires both current and historical execution data. While more difficult to plan, IRR filters are computationally efficient and frequently less costly. A digital filtering system is fed by an input signal. As a result, depending on the time rate of change in the input signal, it will create an output signal with a relatively low bandwidth or relatively broad bandwidth filter. When the input signal gradually changes, the comparatively low bandwidth filter delivers the output signal. As a result, in this assignment, a FIR or IIR filter can be used to remove noise from the provided audio 11.
Methodology. MATLAB was used to analyze the audio signal. Several key commands has been included. Sample data, sample rate. Its function to use to read the audio signal. For the description, sample data is the sample data for signal. Sample rate is the sampling frequency. The file name is the name of the audio file. For group as is audio 11. Next, y equals to FFTX. Its function to shift the zero frequency component to the center of the spectrum. For the description, For the description, X is the input signal. Y is the shift output of the signal X. Next is sounds. Its function to convert signal data to sounds. For the description, sample data is the audio signal. Sample rate is the sampling rate. Next is spectrograms. Its function to use to identify the desired signal, unwanted sinusoidal signal and noise signal. For the description, used to identify the data of sample data and the sample rate. Sample data is the input signal and sample rate is the sampling frequency. Subplot function create an axis in the PTH plane of the graph and divide the axis into NMS rectangular plane matrix. The net axis become the current axis. If P is a vector, it specifies an axis whose position covers all the subgraph position listed in P. Next is ABSY. Its function amplitude of the discrete Fourier transform. Next, M equals to length. Its function used to find the length of the vector. For the description, M is the length of the vector. Sample data is the input vector. Next, N equals to POW2. Its function transforming the length so that the number of samples is a power of 2. This can make the transform computation significantly faster, particularly for sample size with large prime factor. And the last one is filter. Its function used to filter input signals. For the description, B is the numerator of the coefficient, A is the denominator, and sample data is the signal required to be filtered.